Good morning. I'm going to repeat the lesson from yesterday. Like a summary of the lesson from yesterday in class. This is about polynomials. We learned the standard form of the polynomial function p of x equals an x to the n plus an minus 1 x to the n minus 1 and so forth, plus a1 x plus a sub 0, where n, which is the degree of the polynomial, is a non-negative integer number, and all the coefficients an minus 1, a1, a sub 0 are real numbers. The degree is the greatest degree of the monomials. Every one is a monomial, and so you're going to pay attention to the monomial that has the greatest exponent. That monomial is called leading term. The leading term is going to determine the degree of the polynomial, which is going to be the highest degree of all the monomials. And the coefficient of the leading term is the leading coefficient, is also helping us to determine some aspects of the graph of the polynomial. The number of turning points is also determined by the degree of the polynomial. I don't know if you noticed it. I was expecting you guys were noticing this during class yesterday, but I'm going to tell you anyways. N, which is the degree of the polynomial, determines the number of turning points. It can have no more than n minus 1. So, for example, this example we covered yesterday. P of x is 4x to the third power plus 3x squared plus 5x minus 2. The leading term is 4x to the third power, and see, this is, let me write it down. This is P of x equals to 4x cubed plus 3x squared plus 5x minus 2. This was example yesterday. Determine the leading term, which in this case it is in descending order. Not all the time it's in descending order, but in this case it is. So this is the leading term, and the leading coefficient is leading coefficient is equals to 4, and the degree of the polynomial is 3. Right? And also the number of turning points is going to be no more than 2. So it can be 0, or it can be 1, or it can be 2. Say, for example, the degree of a polynomial is 5, then the number of turning points is going to be 0, or 1, or 2, or 3, or 4. It's always less than 1 degree. Less than the degree in 1. We're going to start right now with the first. I'm going to repeat the process that we did yesterday in class, where it says find the end behavior, turning points, and it identify where the function is decreasing or increasing, and what parts of the graph, of the axis, x-axis, the graph is increasing or decreasing. So I'm repeating this in the next video.